This video is about solving quadratic inequalities. I noticed that these videos are starting to get kind of long, so to speed things up quite a bit, I'm going to be doing the factoring without showing you all the steps. You should be able to factor by now. So we're going to be talking today um, about quadratic inequalities, and these really aren't too bad. So the gist is we take our quadratic, we factor it, we apply the zero property, and find its two zeros. We're going to test the values on a number line and kind of plot them like this, okay? And then we're going to multiply our two products together. So negative times negative equals positive, positive times negative equals negative, positive times positive equals positive. And then we will choose the appropriate interval based on that. So um, these are actually pretty cool, right? let's get to actually doing one. I'm not a big fan of these pre-done ones. So let's look at A. So our equation is 2x squared plus x minus 10. So I'm going to go ahead and factor that. And when I do factor that, my two factors are, let me zoom in here, 2x plus 5, and then x minus 2. And if I apply the zero property to those, my two solutions will be x equals negative 5 over 2 and x equals negative 2. So I'm going to go ahead and plot those 2 points on my number line, and I'm going to notice that my inequality symbol has an equal, so it's going to be a solid dot. Okay, so 5 over 2, that's 2.5. So right about here. And x equals, should be x equals positive 2. Geez, Mr. Clark. 2 should be right here. Yeah, I am just not doing well with putting stuff in the right spot today. I even said where it should go, between 2 and 3. There we go. I'm human, I make mistakes too. So for the top one, right, this 2x plus 5, I know that that 0 is negative 5 over 2, so I'm going to put the 0 there. If I go smaller than that, I'm going to be in the negatives. If I go bigger than that, I'm going to be in the positives, right? For my bottom one, that's where x is plus 2. That's my 0. If I go smaller than that, I'm going to have negatives. Less than 0 is negative. And the other way is going to be positives. Okay, so what I'm going to do is I'm going to look at the signs. So negative times negative is positive. Then we hit our 0. Positive times negative is negative. Hit our 0. Positive times positive is positive. Okay, now that we kind of have that graphically, we're going to go back and look at the problem. And it says it should be less than or equal to 0. So less than or equal to 0, right, is going to be negatives. So that would be the stuff in the middle. So I'm going to fill in where my answers are going to be negative. And that's my graph. And if I was going to write that out as an inequality, I'll kind of do that off to the side here. I would say negative 5/2, the littlest, less than or equal to x, less than or equal to 2. And that's going to give us our little conjunction right there. So as we saw in the example we kind of glanced at, they had a disjunction. See, we can't have a disjunction or a conjunction. Open circles, closed circles, all of it applies. So what I'm going to do is go ahead and take a look here at B. X squared plus 3x minus 4. And if I factor that, my two factors are going to be x minus 1 and x plus 4. So my two zeros will be x equals 1 and x equals negative 4. So the big question is this a conjunction or a disjunction? And if we graph it out, Let's see if I can make a number line here and have it not look completely hideous. 1, 2, 3, 1, 2, 3, 4. -4 and 1. We're just going to go like this, you know. These are going to be open circles at -4 and 1. So for my top, we'll do x plus 4 on the top and then x minus 1. At x plus 4, this is going to be my 0. And I'm going to have my positives like this. You can see why graphing these isn't always my favorite. It does get to look kind of messy. And the other one, where x is 1, that's my 0. So I've got all my negatives this way and my positives this way. So I've got positive, positive, 0, negatives, 0, my positives. So the question is, what do I want this to look like? And this is a less than 0, so I want the negative solutions. So my answer is going to be -4 less than or equal to x less than or equal to -4 less than x less than 1. Computer catch up here. I did the same thing I did with A, just a little more ugly, and double checked my values. And I saw this was less than, and I'm looking for numbers that are less than 0. Let's see how number C works. I bet it's going to be different because it's got a greater than. So if I take C, 3x squared plus x minus 10, and I factor that, I get 3x minus 5 and x plus 2. So our zeros here are going to be 5/3 and -2. So if I make my number line, I go 1, 2, 3, 4. We go 1, -2, -3, -4. Let's see. 5/3. There's 3, 4, 5. So right about here. That's going to be a whole circle. And -2 is going to be filled in because of the equal to. I'm going to put the 3x minus 5 on top and the x plus 2 on the bottom. The 3x minus 5, this was the 5/3. There's a 0 here, so it's negative this way and positive this way. The x plus 2 is a 0 here, negative this way, positive this way. So in the grand scheme of things, when I multiply those integer values together, I get negative, 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 0. I'm sorry, positive, 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 negative, 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 0, positive, positive, positive. Kind of like we would have gotten before. And then I'm looking at here, I want greater than 0. So the negatives aren't going to work. It's going to be disjunctive and go out. So where the previous one, I should have colored it in, does this, right? We wanted the negative values. On this one, we want the positive values. So it's going to go like this. So we're going to write that disjunction out. And so our solution, I'll put it off to the side, would be x is greater than 5/3, and also, or x is less than -2. That one's not an and because it's disjunctive. Sorry about that. So let's look down. These farmers, man. All right, so a farmer wants to enclose a rectangular pen next to his barn. A wall of the barn will form one side of the pen, and the other 3 sides will be fenced. He purchased 100 square feet of fencing and has hired Fence Me In to install it so that it encloses an area of at least 1,200 square feet. So Fence Me In makes a pen 50 feet in length, what will be the width of the pen. So what I'm doing in my head, I'm taking this length, right, this 50 out, so I have 50 left, divided by those 2 sides. 50 divided by 2 is 25. That's 25 feet. We also know that the length plus 2 times the width has to equal 100 feet. So we can actually model that equation out as well. And we can find the area the 50 that they already said times 25 equals 1,200, which, hey, that's what they wanted. So that works nicely. Let L represent the length of the feet of the pen, okay? Write an expression for the width of the pen in terms of L. So we kind of already did that. We're going to take our 50 and subtract the length over 2. Bam, that's pretty easy. Half the length, and we're going to take that away from 50, which is essentially what we did before. Number 3, write an inequality in terms of L that represents the possible area of the pen. Explain what each part of your inequality represents. All right, cool. Okay, we're doing area. So that would be length times the width. And that would be greater than or equal to 1,200 square feet. Come on, catch up. So we just recycled the equation that we used, essentially. Write the inequality in standard form. All right, so we're going to have to do some distribution here. That would be 50L minus L squared over 2 is greater than or equal to 1,200. We'll make it look more pretty. We will get, let's see, 100L minus L squared is greater than or equal to 2,400. Let's get that all on one side. 100L minus L squared minus 2,400 is greater than or equal to 0. We'll put it in the right order. Negative L squared plus 100L minus 2,400 is greater than or equal to 0. And then we will fix that to make it be in standard form. L squared minus 100L plus 2,400 is less than or equal to 0. So we took this equation, right? I'm not supposed to have a negative in front. That's not standard form. So I multiplied everything by -1, like we did the other day, which is totally fine, until the end, whenever it finally syncs with my tablet. We had to flip this because if we multiply or divide by a negative, your inequality flips over. So we're going to use factoring to solve the inequality. I'll go ahead and tell you, since I promised I wasn't going to take up a whole lot of time on this one, especially for that last video. If I factor it, I'll get L minus 40 times L minus 60. And I believe that was less than or equal to 0. Use factoring to solve it. Okay, so my two solutions here would be L minus 40 less than or equal to 0. So L, if I add 40 to both sides, is going to be less than or equal to 40. And then L minus 60 is less than or equal to 0. If I add 60 to both sides, I get that L is less than or equal to 60. So there's our possibilities. I'm sorry this thing is taking so long to sync today. I do not know what its problem is. All right, so we need to interpret the solutions of the inequality. That's our next task. The length must be at least 40, and the width must be no more than 60. So it's between 40 and 60, right? Use the possible length to determine some possible widths. The width has to be at least 20 and no greater than 30. And I say that because of the dividing by 2 aspect when it comes to the length and the width, right? Just like we did up there, we had 2, I believe, widths and 1 length. Pretty straightforward here. And I think that is going to be it for us. I will let you to practice.